The theory that we're going to use to explain how gases behave is called kinetic molecular theory. Kinetic referring to motion, and molecular referring to molecules. So we understand gases in terms of the motion of the molecules or the particles. And this model works pretty well for most gases under many conditions. Of course, it's not perfect, but we're just going to look at where it does work. So this is kinetic molecular theory. Gases are a collection of particles in constant motion. So you can think of them as little marbles if you want, or airsoft pellets or something, and they're just moving. They're in constant motion. There are no attractions or repulsions between the particles. Collisions are elastic, like billiard ball collisions. When these two things bump into each other, the two particles, they just bounce off. Okay? Energy can be transferred from one to the other, but you don't lose any energy. There's a lot of space between the particles compared to the size of the particles themselves. So here's the particles, there's a lot of space in between. This is different than in liquids, where they're close. And the speed of the particles increases with increasing temperature. So temperature is a measure of the average kinetic energy of a substance. So if you heat the gas, the particles move faster. Any questions yet? So this theory is consistent with what we observe as properties of gases. Gases are compressible. You have a gas in a cylinder, you can push down on the plunger here, the piston, and you can squeeze the gas together. Why can you do that? Because there's a bunch of empty space between the particles, right? And so here we're forcing the particles to be closer together. You can't do that with a liquid, because they're already touchingly close. There's not any empty space that you can squeeze out, okay? Gases take on the shape of their container. Why does this happen? Well, the gas particles are in constant motion. They travel in straight lines until they bump into something. They don't slow down. There's no wind resistance. They are the wind. You think about a baseball, you throw a baseball, you shoot a bullet, and there is resistance as it goes through the air, and gravity's pulling on it, and it slows down and eventually falls to Earth. That doesn't happen with gas particles. They just keep moving until they bounce into something. And they're not attracted to each other, and so they're not going to clump up in the bottom. They're just going to bounce around. They're going to fill the container, and they're going to take on the shape of the container. Gases have very low densities compared to liquids and solids, and that is because of so much empty space. So if you took one can of soda, the author apparently really likes orange soda. I would make this Diet Dr. Pepper, but it's not my book. So if you took one can of soda, the soda in one can, and that's a liquid, so the particles are really close together, and you made it into a gas, it would occupy the space of 1,700 cans of soda. That's how much empty space there is between the gas particles. So, we can see each other through the air in the room, right? Because it's mostly empty space.